Hello and welcome back. First of all, I would like to thank you for supporting me in doing this good job. I want you to know that I always try to bring accurate and clear information to you. The sole purpose of me creating these videos is to help you understand those concepts that you always wanted to learn. At the end of this video, if you find it helpful, please do like, comment and share. If you are new to this channel, also hit the subscribe button in right bottom corner. With that being said, let's see what we have got today. This session is going to be about commands to troubleshoot phase 2. I'm going to use this setup. So I have two ASAs, they have a VPN tunnel between them, and these are the devices that are going to talk to each other. So currently my VPN has been set up in such a way that if I try to initiate traffic right now, it is going to come up just fine. Since we want to have some problems, I want to show you in real time what may or may not happen. To see that, I have to create some problems, and then I'll show you how you can use commands to figure out the problem and then eventually fix it. Let's first check if my VPN can really come up if I initiate some traffic. So what traffic do I need to initiate? I'm going to ping from this PC whose IP address is 192.168.1.10 to 10.10.10.20. And this PC is down, so ping will really not work, but at least it will, it should bring the tunnel up, because this PC is up, this router is up, ASA1 is up, ASA2 is up. So the VPN is between these two ASAs. So at least VPN tunnel should come up. I know this router is down, so it's purposefully down, and so are these other PCs. So let's go back and initiate some traffic from this PC whose IP address is 192.168.1.10. This one. Send a ping to 10.10.10.20. I'm going to make it a continuous ping. So the ping will not work. We know that. Timeout. Go to ASA1. Check phase 1 status. Show crypto IKEV1 SA. Phase 1 is up. That's why it says active, main mode active. Now I need to check phase 2. We have already done another video on phase 1. So in this video, I'm going to focus on phase 2. So how do you check if your phase 2 is up or not? Show crypto IPsec SA. And it shows if there is any output like this. If you have any packet in cap, decap, that means your phase 2 is up. If you have too many tunnels on your ASA, then this command is not really useful. You'll have to tweak the command a little. So you'll say show crypto IPsec SA peer and the peer IP 1.1.1.2. And then it is going to show you the output just specific to your particular VPN peer. It shows you which crypto map is being hit, which crypto map is triggering this VPN. So crypto map name is my map. It's at sequence number 10. Your local address is 1.1.1.1. The crypto access list is AWS VPN. Current peer IP is 1.1.1.2. Packet in caps, packet decaps. 45 in caps, 0 decap. Right? Then you have these SPI values here. So inbound SPI, outbound SPI. These are also important. If you don't see them here, your phase 2 is improper. So right now this command is just to check if your phase 2 is up or not. In phase 2, there can be two problems. One, phase 2 isn't coming up, and two, phase 2 is up, but the traffic isn't working. So if your phase 2 is up and traffic is not working, then that also comes under a phase 2 problem. So your main command for phase 2 is show crypto IPsec SA peer and the peer IP. That is going to be your main command to troubleshoot most of the phase 2 problems. Let me quickly create a scenario where phase 2 doesn't come up. Then which commands do we use? So I'm going to pause the recording for the moment while I'm creating that scenario, and then I'll resume it. Alright, so I have made some changes in the configuration and phase 2 shouldn't come up now. But let's see what's going on. So we don't know if phase 2 is coming up or phase 1 is coming up or not, or what the problem is. All we need to do is troubleshoot. right? So customer says that my ping is not working and you have access to both the ASAs. So he's running a ping. I don't know from where to where. So let's figure out first the main things. Let's say this is a live environment. You have too many VPN tunnels in there, right? So it's not going to be very easy to find your tunnel. But what can be easy is you can ask the customer the source IP and the destination IP, right? From which IP address is he running the ping and which IP address he trying to reach. So let's get that information here on the screen. 192.168.1.10 and the destination is 10.10.10.20. What did I tell you in my last video? First you have to start checking with phase 1 status. So I say show crypto ICKMP SA. It says there are no IKEV1 essays. Show crypto ICKMP SA. I'm going very fast. So you see when I'm going very fast, I might just see it sometimes. So let's skip it for a few seconds and try it again. So it was once when I saw that active, but now I don't see it. So when you don't see it, next thing you do is run a packet tracer. So figure out the routing, show route 192.168.1.10. So this is on inside, right? It's learning the route from inside. Then I want show route 10.10.10.20. Network not in table, that means it's taking the default route. So let's check the default route. I say show route. Default route is pointing to outside. So now I know the routing. Packet tracer input inside. What type of traffic am I running? ICMP. What's the source IP? 192.168.1.10. This is ICMP echo request, so it's going to be 80. And then destination is 10.10.10.20. I want detail. So it says access list allow. Then there is a NAT which is coming into the picture. What this NAT is doing, it says change 192.168.1.10 into 172.116.1.10. So that is changing our real IP to another IP, 172.116.1.10. When it is going to a destination, specific destination is 10.10.10.20, and do not change the destination. So that's what it means. Okay, so now we know that our real IP is not going to be there when it reaches to the destination. It is going to be natted to 172.168.1.10. And I'm interested in seeing VPN phase. So say VPN encrypt drop. Very nice. And the final reason is Acl drop. So this is a very generic reason. You don't have to rely on it that there is an access list that's really dropping it. What do you do next? You take debugs. So you don't simply do the debugs for everything. You have to be very you have to do conditional debugs. So how do you do conditional debugs? Like I explained in my last video that you do debug crypto condition peer and the peer IP. Peer IP is 1.1.1.2. And then you do your normal debug. So debug crypto ICKMP 128 I want to do. So this is my phase 1 debugs and it's coming very fast, and that should be enough for me to figure out what's going on. So I'll just scroll a little up and go through the debugs where it is saying session is being turned down. Reason user requested, right? Let's move a little bit up. I remember seeing main mode active. That means phase 1 did come up. We should see that in debugs as well. So yes, here it is. It says phase 1 completed. So when your phase 2 is going down, when there is a mismatch in phase 2, or for some reason phase 2 is going down, then you may see that when you do show crypto ICKMP SA, it will not show you active because the phase 1 is coming up and going down very fast, right? But you can see that in the debug that phase 1 completes. So if the debugs are saying that phase 1 completed, that means there is nothing wrong with the phase 1. Now your focus should be on phase 2. So you see received non-routine notify message, no proposal chosen 14. This usually indicates a phase 2 mismatch. It can be anything in phase 2. Most likely this indicates a mismatch in crypto ACL or encryption algorithms or hashing. So phase 2 parameters basically. Another indication of a mismatch is clearly says here removing peer from correlator table failed, no match. That means again something doesn't match in phase 2. You have to apply conditional debugs. Once you have conditional debugs, if you need to turn off the debugs, you'll just say unall quickly. That turns off the debugs. You can also type undebug all. They both do the same thing. So now we know there is a mismatch in phase 2. How do I figure out what's the mismatch? So to do that, we need access to both the ASAs. So let me get into the ASA2. I'm gonna put them together. You know what, for your convention, I'll just rename this ASA1, ASA2. And this guy is PC1. Its IP address is 192.168.1.10, I believe. From this PC, I have continuous pings going on. They're timing out. I'm pinging 10.10.10.20, so you know that. Alright, still if you do show crypto ICMP SA to check phase 1, it doesn't show anything. Sometimes if you're very lucky, you might see something in here. What should be your next step once you have seen the debugs and figured out it's a phase 2 problem? You compare phase 2 configuration. How do you compare the config? If you have access to both the devices, both the firewalls, then it's a good thing. Or otherwise, it's gonna be a time-taking process that you send your config to them or ask them for their config, and then you compare it. So let's keep it simple that we have access to both the devices, both the ASAs, and I know the peer IP. So I'll say show run crypto map pipe include and type in your peer IP because you will have too many VPNs on your ASA. So this is the best way to figure out the complete configuration for your particular VPN peer. So it says this peer is in cryptomap my map at sequence number 10. So this time I'm gonna say show run cryptomap pipe include my map sequence number 10 because I figured that out from here. And now it's going to show me all the commands related to my map 10. That tells me what is the crypto ACL, AWS underscore VPN. What's the peer IP and what's the transform set. So these are your phase 2 parameters, this crypto access list and transform set. So first thing that you're gonna match or compare is this, both of them. So I'll start comparing the crypto access list. So I'll say show access list and AWS underscore VPN. Let's go to the access list on ASA2. So here, show run crypto map pipe include 1.1.1.1. Show run crypto map pipe include my map 10 and show access list Raj underscore VPN. So these access list must be mirror image of each other. So this one says from 10.10.10 to 172.16.1.0. Let me just highlight this and then we compare it. So from 10.10, so this one should be to 10.10. That looks okay. Say /24. You must also match the subnet mask. Then it is 172.16.1.0/24, 172.16.1.0/24. So this one looks okay. Go for the next one, 191.168.2.0 going to 10.10.20.0. and this one is 20.0 going to 2.0. So crypto ACLs look okay. Next thing I'm gonna check is the transform set. Transform set name is set2 here, but how do I know what parameters are in there? So to check that, you will say show run crypto IPsec pipe include your transform set name set2. So that shows you what parameters are configured for transform set. So it says AES and MD5. Let's check here. Transform set name is my set. Show run crypto IPsec pipe include my set. This one has AES SHA. Wait a second. Did I see MD5 here? Yes. So there is a mismatch in the transform set. So this one is using MD5, this one using SHA. So let's correct it. I want to use SHA. I don't want to use MD5. So let's fix this guy here. So the way you change transform set is copy paste ESP SHA HMAC, and that should do it. To make sure that the config is correct now, check it again. Show on crypto IPsec pipe include name of the transform set. So this one has AES and SHA. Go to ASA1, and this also has AES and SHA. Now they are a match. So the VPN tunnel should come up now. Let's check the ping. Well, ping is still not working because the next router after ASA2 is shut down, and the actual destination that we're trying to ping is also down. So don't expect ping to work. Well, I'm not. Let's check the VPN status now. So first I would like to check phase 1, show crypto ISIG MBSA. Phase 1 is up because it says active. You know, in your phase 1, you have defined a lifetime, right? So that lifetime is for phase 1 to rekey. After these many minutes, phase 1 will rekey. So it will not renegotiate, just rekey. The keys will be generated again. And where can you see that timer? So that timer can be seen with the command show vpn-session db detail L2L, and you have to say filter, and you can say IP address, pure IP. So this is here. So here you see the details. It says rekey interval 86-400 seconds. So this is the phase 1 lifetime that we set, and it says rekey left 86 to 49 seconds. So it started from 86-400 seconds, and now I think approx 200 seconds have passed. So this is the time left to rekey. Phase 1 will rekey after these many seconds. You can also see the duration, how long this VPN has been up. When did this VPN tunnel start? So it started at this time. Then you see bytes TX and bytes RX. So how many bytes have been sent, how many bytes have been received. So we haven't received anything, we're just sending, and that makes sense because the router on the other end is down, so there are no replies back. So but it looks like we are sending, right? Then this one shows you your phase 1 status. So for phase 1, you're sending on UDP port 500, source port 500, destination port 500. Authentication mode is pre-shared key, and encryption, this is main mode, right? Negotiation main mode. Encryption AES 128, hashing SHA. Jeffy Hellman group negotiated 2. Filter name, there is a VPN filter applied, AWS VPN underscore filter. And then this is your phase 2. So for phase 2, you have a crypto access list. So this is the crypto access list for which the traffic has been seen. So the traffic has been seen for from 170 to 16.1.0 going to 10.10.10.0. Encryption, this is phase 2 encryption, phase 2 hashing, phase 2 encapsulation mode. So this is tunnel mode. Then you have rekey interval. So phase 2 is supposed to be rekey after 28,800 seconds. Rekey left. So this is time to rekey left. And this is rekey interval for kilobyte for data. Once this much data has been transferred, then the phase 2 will rekey. Idle time of 30 minutes. If there is no data transferred in phase 2, for 30 minutes, then phase 2 is going to go down. Bytes RX, so we have not received anything. Bytes TX, we are only sending the traffic. 76 packets we have sent, we have not received a single one. That's how you can check. We have verified that the phase 1 is up, show crypto ICKMB SA. Phase 1 is up, active. Now we're gonna look for phase 2. So to check phase 2, you have to say show crypto IPsec SA. But remember, in real-time environment, you will have too many VPN tunnels, and running this command will show you the output for all the VPNs. You don't want to see that. You want to see the output just for a specific VPN tunnel, right? So to do that, you have to say show crypto IPsec SA peer and the peer IP 1.1.1.2. Then it's going to show you the output for just for a single peer. It says crypto map tag, crypto map name is my map, sequence number 10. If someone gives you this output, let's say your customer has shared you this output. So looking at this output, you can clearly tell what's the problem. At least you can figure out where the problem is. Let's say they've given you this output. From this one, I see crypto map name. I can find what sequence number. I can find what's my local IP address. What is the crypto access list name? For which crypto access list we are seeing the traffic. So it says packets incap to 67, packets decap 0. Wait a second. So this packet incap or packet encrypt, we are encrypting packets. So we have encrypted to 67 packets, but there are no decryptions. That means only we are sending. We are not getting any reply back. That's what it means. It makes it very simple. Because it's we are sending, if we are not getting any packet, we are not getting any encrypted packets to decrypt, then how do you expect the traffic to work? The outbound SPI is the one that we're using while encrypting the traffic, and inbound SPI is the one that we're using to decrypt the traffic. So our outbound SPI will be the inbound SPI on the remote end. They have to be same. SPI that we're using to encrypt the traffic must be same as the other end is using to decrypt the traffic. So outbound SPI on our end should be same as the inbound SPI on the other end. So we'll check that out. We are on ASA1 right now. The outbound SPI ends with 97. We're gonna look at ASA2 now, and the inbound SPI should be 97. Show crypto IPsec SA peer IP 1.1.1. Enter. Look at the SPIs now. So here current inbound SPI 3E55AA97. 3E55AA97. So the outbound SPI here must be same as inbound SPI here. That's how the ASA figures out that for which entry in the crypto ACL I have to decrypt this traffic to. For each entry in the crypto access list, you will have different inbound and outbound SPI. But the inbound SPI on one end must match the outbound SPI on the other end. Okay. Another thing that must match is the number of incaps here on one side must match the number of decaps on the other side, and vice versa. So I'm just going to run the command once again. Number of incaps here is 397. I'm going to go to ASA2 and run the command once again. Number of decaps here are 400. So what did I say? Number of incaps on one end must match the number of decaps on the other end. So you see, because I ran this command a few seconds later, so meanwhile it also received 3 packets. But if I go and stop the ping now, there should be no other traffic. So packets incap 415 on ASA1. If I go to ASA2 now and see packets decap, so 415. This must match. If you see ASA1 has packet incaps 415 and ASA2 has packets decap 414, that means one packet has been dropped. And dropped where? It's probably dropped by ISP, because this is encrypted traffic we're talking about. These packets tell you how many encrypted packets you have received and that you have decrypted. And same way, this number of incaps must match here. So if that's not matching, there's a problem with the ISP or somewhere in the path. One more shortcut that you can use here. So this shortcut is for the command that I just shown you. The important part that we want to look at is usually this one. So you usually want to see what crypto access list has been negotiated, for which ACL, from which entry in the crypto ACL we are sending the traffic. So this is one thing that I would like to see. That will give me a fair idea for which I'm observing the traffic. Then I want to see number of in caps and decaps. So I can run this command in this way. I say pipe include ident pipe pkts, and you will see just that output. Isn't that cool? And skip everything else and just show what that matters to you. So it shows me local identity, remote identity, packets in caps, packet decap. And that's all I need to see. That for this particular access list, when the traffic is going from 172.16.1.0 to 10.10.10.0, how many packets are getting in cap and decap? Or are there any in caps or decap? Because I only initiated the traffic that matches this particular entry in the crypto ACL, that's why I'm saying here. So if you see, my crypto access list actually had 2 entries, but here you're only seeing one, which is from 172 to 16.1.0. So this one, 1.0, going to 10.10.10.0, this one. In fact, you must match the subnet mask as well, right? So it's /24 here, /24 here, and same goes here. You also see there are hit counts, 796. And on this one, there are no hit counts. That means there has been no traffic for this particular entry in the crypto ACL. And that's why for this, SA have not come up. So these are security associations bounded with the entry in the crypto ACL. So the SA for second one has not come up because there has been no traffic. So whenever there will be any traffic, then only these SAs will come up. So you will see this kind of entries for the second crypto ACL entry as well. I plan to bring more videos on this particular topic. There is a very specific problem in phase 2 that I'm going to discuss in my next video. So that's going to be very detailed, and it will give you better idea about what these SPI values are and where do you look at them, how do you look at them, how they are useful when you're doing troubleshooting. So do subscribe to my channel. That's all for now. I hope this has been informative to you, and I would like to thank you for watching it. It is your support, your likes, comments that keep me motivated for bringing up more stuff like this. Please let me know if this has helped you. If you are new to this channel, also hit the subscribe button in right bottom corner.